All right. So in in our last class, all right, in our last class, we looked at AWS VPC, and we even ran a website on EC2. All right. So currently, our application is what? Is up and running. So let us assume we have a VPC. Okay. Then we have an EC2 instance. Then inside our EC2 instance, we have a web app. So our application is what? Up and running. And before we continue, I want to believe by now nobody has any confusion or any sort of issue relating to the VPC class. So no, we gave ourselves a lot of time, all right, to assimilate everything we did. And I was hoping that by now I'm going to see lots of LinkedIn posts about the last class, but I think only few persons did that. But that's just by the way. You know, when we started this class, I emphasized on the importance of documentation. All right. So we are not going to go over that again. All right. So the thing is, treat documentation the way you are treating your learning path. All right. So let's continue. So your application is up and running because we have what? Just one EC2 instance. Now let us imagine that your application suddenly gets very popular. Your application gets very popular. Now let me also imagine that this guy can only serve, let's say, 100 users very perfectly. All right. So you started with 10 users. Your application gets very popular. Hundreds of users joined. Then from hundreds, you get to have 1,000 users still running very fine with some degree of latency. Then, maybe due to how good your application is, your application gets really, really popular and you start getting 10,000 visits per day. What do you think will happen? Can someone try?
It will slow the application down.
Exactly. So now, because of the amount of requests your server is receiving, maybe per seconds, per minute, all right, your server is definitely going to slow down. And your website is running inside this server, all right? So that means your server's performance is directly proportional to what? The application running inside the server. So if this server should slow down, your application also slows down. Now, on the user side, if users want to visit your application, your users will definitely do what? Get frustrated. Some requests may even fail. All right? Some requests may even fail. This is where the concept of load balancing comes in. I know most of us may have seen um, um, some requests. If we see request that begins with, let's say 100, all right? 100 simply means something like continue. We've been seeing something like 301. What does 301 mean? 301 is more like a redirect. All right? Simply say, okay, maybe this domain has moved or this application has moved. Then we'll be seeing things like, I know 404 is very common. Even most of us that are really not into IT, if this is the first time. Yeah, 404 is very common. 404 means not found. Maybe your application is not found or something. Okay? So Another popular one is 500. 500. 500 is for server errors. Let's say internal server error. So if a request, let's say maybe at the user end, the request is it's failing. All right. So it can be 500. All right. So now a very quick catch. If you see any request that starts with 100, so it's related to things like continue and all sort of that. Okay. So if you see requests, okay, I forgot another one, 200. 200 means okay. Okay. So 300, anything that starts with 3 is more of redirection. Anything that starts with 4 is more of cleanse errors, like from the user side. All right. Anything that starts with 5, they are more of server errors. So I'm very sure we've been seeing things like 500, 404. 301 is not very common. And 200, you may not really see 200 because, okay, when we start application deployments very deeply, then you're also going to see 200. But then these are just by the ways. So I just had to. So these are known as HTTP requests or HTTP status. Okay, so you can read more on this. But then let us continue. Um, so let's assume your server started receiving requests of, let's say, 10,000 users. What happens is that this server slows down. Sometimes it gets 500 error status. All right. Now, what this is trying to tell you is that the one server you provision is not enough, is no longer enough to accommodate users. All right. So now, what do? We don't just upgrade the server. You can simply add more servers. Now, this is what I mean by adding more servers. We had just one server here running our application. I'll call this application W for web app. So initially, this is what the servers or what the users were visiting. Now you add another server. In this server, you also run the same application we were running. You can decide to add another server here. So that means the first server has what? The copy of the application. The second server has what? Another copy of the application, the same copy of the application. And the third guy has the same copy of the application. Let us add another server. So that means these 4 guys has what? The same copy of your application. But now, we now have another problem. Now, let us assume that this guy has an IP address of, let me just, for convenience, I will just say 1. This guy has an IP address of 2. This guy has an IP address of 3. This guy has an IP address of 4. Now, when we were dealing with just one server, it was very easy, all right, for us to do what? Tell the users, okay, you can go to this server and you see our application running. Okay. Now, how do we tell users, now that we have 4 servers, how do we tell the users which server to go? Because I cannot advertise these 4 servers. Let's assume, okay, I can go to a marketplace or not just a marketplace. I can start advertising my servers. Since one server was literally slowing down application, we've now added 4 servers to our application. So that means you can visit our application with 1. You can also visit the same application with 2. You can also visit the same application with 3 and 4. Now, you have advertised your server's endpoint, but then you do not explicitly tell the users which server to go, because we are humans. Now, you can as well has what? 5,000 users visit the first servers. You can as well has what? 1,000 users visit the second server. Now, since this other server is not really that popular, you can have just 10 people visiting this server. Then you can have 300 users visiting this server. That means we have not fully solved the issue with what? Our request slowing down. Even if you look at server 4 is receiving fewer requests. Well, server 3 is also receiving fewer requests, but much of the request is going to what? Server 1. So this is where we introduce what? Load balancing. Now, what is a load balancer? Let me take this out. Again, let us assume we have server 1, server 2, server 3, server 4. Now, each of them running the same application. Now, we don't explicitly tell the users to go to each of these servers. Instead, we can provision something called a load balancer. A load balancer can also be a server. All right? I will call this LB for load balancer. Now, what does the load balancer do? Instead of our users to visit these guys directly, what does our user do? Our user visits this guy. Let's assume this is our user. Our user visits what? This server, which is the load balancer. Now, what does the load balancer do? The load balancer is going to do what? Distribute each request coming to these servers. So depending on the load server algorithm you use, let's say the first request comes in, it goes to this other server. Second request, what I mean by request is users trying to visit these servers, all right? Users trying to visit these servers. Now, when for instance, I have a website, all right? When I'm trying to visit something like, let's say, google.com, I'm practically sending a request to Google. Okay, so this is a very typical request. All right. So, so what happens is that this load balancer is going to ensure that none of these servers is what? Overloaded with requests. So to recap, a load server is going to do what? Distribute traffics, incoming traffics to each of these servers. It does not matter the amount of server you have. When you add another server here, it is also going to be added to this hub. All right. So now, a typical term to refer to this server is backend servers. Backend servers. So, before we move forward, I don't know if there's any question. Is there any question?
Not over here.
All right. Okay. So now we have different types of load balancers. Now, we have the network load balancer. All right. We have the network load balancer. Types. Now, this concept is always going to come up in your DevOps journey. Okay, so just try to grasp the load balancing concept. So we have the network load balancer, and we have the application load balancer. Okay, so the network load balancer, now both of them do the same thing, but then the network load balancer is very fast, okay, and it is very simple to configure. Now, the application load balancer is what? It is smarter than the network load balancer. So it is smarter and very intelligent. So another thing you should also take note is that the network load balancer works at the layer 7. Now, for most of us that are very conversant with the OSI model of application deployment, then you definitely know what happens at layer 7. Then the application load balancer, the network load balancer works at layer 4, not layer 7. All right. So the application load balancer works at layer 7. Yeah. So the main difference between the application load balancer and the network load balancer is, let us try to see it. Let's assume we have different applications. All right. Or this is our servers. So I can simply say, okay, this server is used for this particular endpoint /API. And say, okay, this other server can be used for this endpoint /dashboard. So what an application load balancer, since it is very intelligent than the network load balancer, so what it's going to do is, if a user is trying to visit, let's say, google.com/API, is going to take that user to this particular server. If another user is trying to visit google.com/dashboard, is going to take them to this server. Now, if you are very confused, don't be. Let us look at something very practical. Now, we've seen google.com, right? If we see google.com, now if Google is using an application load balancer, maybe Google can provision one server for their homepage. So if you are trying to visit Google homepage, it's going to take you to that server that is hosting that homepage. All right. Now, if we are trying to visit Google Meet, let's say, or docs.google.com. So this is a very different application entirely. So it's going to take us to another application, which is the docs. So this is what the application load balancer do. It is very intelligent. That is, it knows different endpoints you are trying to visit. But then the network load balancer is just at the layer 4. That is the transport layer. Now, if you are still very confused, you can read on the OSI model. It is not very hard. All right. It is really not very hard to grasp. So OSI means open system interconnection. All right. It is made of 7 layers. All right. It is a 7-layer framework that standardizes computer network communication. So you can just read it on the surface. So this is a typical OSI model. So when I say that the network load balancer works at layer 4, this is what I mean. Now, this is the layer 4, which is transport layer. So this layer 4 is in charge of what? Your networks, which is your TCP and your UDP. All right. So the network load balancer works on this level. Now, this is the application. This is what the user sees, the application layer, which is this application here, how we are interacting with this application. All right. So if you want, you can read up on it, but it is really not a must. It does not have anything to do with whatever we are doing. But if you want a clearer picture of how communication works deep, then you can read on the OSI model. So let us continue what we have. So we've seen the types of load balancers. All right. Now, the real thing is a load balancer is useless without what? There's what we know as decision making. A load balancer's decision making, all right, which is often referred to as algorithm. Algorithm is how a particular decision is going to be carried out. All right. So a load balancer must have what? It's an algorithm. And we have different algorithms. All right. So what algorithm simply says is which server should handle a particular request. This is just what the algorithm is all about. How servers should handle a particular request. This is just what the algorithm is all about. Now we have the most common type of algorithm. The first one is known as round robin. Round robin. Now, round robin is very popular in software engineering. All right, but then since we are in DevOps, round robin simply means that requests are distributed one after the other. So it's more like the cyclic method. Cyclic or cyclic mode. Okay. So let us assume we have server 1, then server 2, server 3, and server 4. Now, this is what round robin says. We have what? Our load balancer here, and we have users trying to access this application. All right. Now, round robin says that the very first request should go to the first server. The second request should go to this other server. The third request should come here. The fourth request should come here. Now, this is what cyclic mode says. Now, since we have just 4 servers, 4 requests has been handled. The next request that comes, that is the 5th request, should go back to what? The first server. So it goes this way. So this is what the cyclic mode says. Now, let us assume that one of these servers is bad, because what the load balancer is going to do, the load balancer is going to constantly check the health situation of these servers. By health, I mean if the server is still on, if the server is bad, if the server has network. All right. So those are health checks. Now let's assume that server 4 is bad. All right. So the load balancer is not going to do what? Send requests to this server. Instead, it's going to stop at server 3 and rotate again. Is there any question when it comes to round robin?
Sorry.
Okay.
Yeah. With previous knowledge, which one that when the health check did not pass, it will automatically create a new server?
Oh, that's different from, that is when we start considering things like scaling.
Okay.
Yeah. So that is a very different concept.
All right.
Okay. Please, do we understand? Is there any other question? All right. So round robin is the most common method you always see in load balancing. Round robin is very common. But then, the thing with round robin is that round robin is very fast. All right. It ensures fair distribution of requests. Of course, we saw that already. But then, round robin does not care if your server is slow or even overloaded. What round robin is after your requests going in a cyclic mode. All right. So this is round robin for us. Now the next type of algorithm we'll look at is weighted round robin. Weighted. This is the most advanced round robin. Now, in the weighted round robin, before we come to weighted round robin, in this one, the first one, round robin will definitely perform very well if all these servers are equal. By equal, I mean server 1 has 2 gig of RAM, server 2 has 2 gig of RAM, like they are very much equal. Now, if server 1 should have 1 gig of RAM, server 2 has 2 gig of RAM, and so on and so forth, round robin will not really work very well as expected. All right. Now we have, this is where the weighted round robin comes in. Now the weighted round robin also goes through the cyclic mode. But with the weighted round robin, not all servers are equal. Okay. Not all servers are equal. Now, let us assume that this server is very much powerful than server B. Okay. Now, these weights are always in 1 to 100. 100 means that this guy is very more powerful. If I use 10 here, it means that this guy is not really that powerful. So we should understand weights. So that means this guy will definitely care about what? If a particular server is slow or even overloaded. All right, because of this weight here. So that means server 1 is going to handle much requests than server 4. Is there any question? Okay. So we have another type of algorithm called the list connections. Now, what is list connections? Now, list connection is going to do what? Send requests to the server with the fewest connections. So this is what I'm trying to say. Let's assume we have 1 server, 2, 3. We have a load balancer here, and requests are coming in. Okay. Now let's say that this guy has 1,000 requests. This guy has 500 requests. This guy has 100 requests. Now, looking at server 1 to 3, which of the servers has fewer connection?
Oh, the 100.
The last one.
100.
100.
Yeah. So that means the list connection algorithm says that the next server, or the next request should go to what? The server with the least active connections. That is, it is going to avoid the server with the overloaded requests as much as possible. So that means if another person is trying to view our application, then the load balancer is definitely going to direct the person to server C, because server C has what? The least connections. Is there any question? Now we also have another algorithm method, which is not so popular, which is the least response time. Now the least response time actually features your load balancer. Your load balancer is going to choose the server that has what? That responds very fast. All right. It's going to also choose the server that has fewer response, but also responds very, very fast. All right. So if you have applications that is performance critical applications like your gaming applications, all those stuffs, your finance application, then the least response times is the way to go. Then we have another one that is not so popular, which is the IP hash. What does IP hash say? So let's assume that we have different servers. Let me take this out. Let's assume we have different servers. 1, 2, 3. Now, with the IP hash, let me assume that this is my IP address. This is our load balancer, and I am a user here. All right. And from inception, my IP address is what? Let's say 2. okay, and this server, and let's say I tried to visit this server or my application, and of course, the load balancer is going to direct me to any of these servers. And let's say the load balancer directed me to this server, okay. Now this server is going to record my IP address, which is 2. So now IP hash says that whenever I'm coming back, load balancer should still direct me to this server, which had my IP address. Okay. So these are used for things like maybe if you want a particular user, maybe when a user logs in, that user should stay on that same server. It is used for things like session persistence. If you want a particular session to persist, maybe you're trying to make payments or something, all right, then that type of load balancing is very okay. So to recap, round robin equal sharing, weighted round robin is used for maybe power, is used based on power. Now the least connection is based on the load, all right? IP hash is more of same user, same server.
Oh, Sam, sorry, excuse me, Sam.
Yeah.
The IP hash, is it like the same architecture that is being used for, let's say, for instance, like dedicated servers or scheduled servers and stuff like that for people that has maybe free tiers or those that are actually paid for some services?
Yeah, something like that, but a little bit more advanced than that. Yeah, something like that. So please, before we move forward, is there any question on load balancing?
No.
All right. So now, since we've considered load balancing, let us look at what? Reverse proxy. So what is a reverse proxy? Now, a reverse proxy is a server, all right, that sits in front of your servers. So what a reverse proxy do is to handle requests on your behalf. So reverse proxy handles requests on your behalf. So instead of users talking directly to your servers, what happens? They talk to the reverse proxy first. Now, this concept is much more similar to the load balancing, but there are two different concepts. Let us assume that this is our reverse proxy server. This is our main server. All right. Now, this is our user. So let me take this guy out first. Now, if I want to access the application running here, what do? I can directly, just like what we did in our last VPC class, I can do what? I can directly get this guy's IP address and access the application here. But if we introduce the concept of reverse proxy, you're going to introduce another server here. So instead of me visiting this guy, what do? I visit this guy now, and this particular guy relay our request to our server. Now, even if the server wants to talk back to us, the server do what? Talks back to this other server. Okay. And this server now relay the response to us. So it's more like a personal assistant. This can be a personal assistant. You can picture this guy as those bosses that does not like you talking to them directly. So what happens? You do what? If you want to talk to this boss, you talk to the PA first. The personal assistant relates your request to this boss. If the boss likes you, talks back to the personal assistant, then do what? The personal assistant relay the information of or the response from the boss to you. Okay? So this is just what happens. But in load balancing, what does load balancer do? It distributes traffic. Okay? So what does a reverse proxy do? A reverse proxy sits in front of your server, okay, and relay requests. So a load balancer balances traffic, reverse proxy relays requests. Is there any question?
I have a question.
From my side, no question.
All right. So now,
Hello.
yeah.
Okay, I just want you to go over, just briefly go over the explanation again about what you just illustrated.
All right. So I have a server. Now, from the VPC stuff we did, we launched an EC2 instance. What do? If you get the public IP, right? And whenever someone wants to visit your website, what does the person do? The person visits your website using the IP address, the public IP of your EC2 instance. Am I correct? So there was literally no reverse proxy there. Now a reverse proxy acts as another source of what? Security. So instead of you or instead of someone accessing your server directly, okay, you can do what? You can provision another server here in between the user and your application. So that whenever someone wants to visit your application, the person do what? Visits this application or this proxy, and the proxy relays the application to the person. So now, even if an attacker should come, what the attacker is seeing is the reverse proxy. The attacker is not doing what? The attacker is not seeing your server. Is there any question again?
No, sir, I understand. So,
All right.
So an Nginx server can act as a reverse proxy server, right?
What?
An Nginx.
Yes.
Yeah.
Yes.
Can act as a reverse
Yes.
proxy.
So now, I was actually going to that. So now, some organizations may want to provision, let's say if you are working in the on-premises organization, all right? So some organizations may want to provision a typical hardware for reverse proxy and also provision another hardware for what? For load balancing. All right, but then there are tools that works both. For instance, Nginx. You can configure a particular server running Nginx to act as what? A load balancer and also a reverse proxy. Now, we have things like Nginx. Nginx can act as what? A reverse proxy and also balances load. Then a very popular tool is called HA proxy. HA proxy can also work as a reverse proxy. Can also configure it to balance your load. Okay, so I don't know if we've heard of things like traffic. Don't know if we heard of things like F5. So all these guys are reverse proxies and can also work as a load balancer. Is there any question? Please, are we following? We are very quiet today.
Yes, we're following.
All right, so let us try to practicalize all what we've done. So now, in a very typical environment, let us look at how we can implement this. I'll bring up draw.io. So this is not going to be because of time, all right. So I'm not going to do this the way it ought to be done, all right. But when you're implementing yours, I want to include everything. Now, this is what I want to implement. I'll bring up VPC. So this is going to be a VPC. Remember, when we were talking about VPC, we said that things like load balancers should be what? Should be in the public subnet. Can we recall? Are we still here?
Yeah, we're here.
So you're going to have two subnets. So one is going to be what? Public subnet, and one is going to be your private subnet. So this is going to be a public. All right. So this is going to be our private subnet. All right. So now we can have our EC2 instance already. You know what to configure. So that means we are going to provision a server, then configure that server to be a load balancer. So now we are going to use two approaches to this. Now, before we come back to this, we are going to use HA proxy for our load balancer and our reverse proxy. Now this happens if you don't want to use the AWS native tool. Now, AWS has its own native tool called Load Balancer. So you can create a load balancer on AWS, configure it, and it still works. So this is a little bit cheaper than you provisioning an EC2 instance, okay? But I would love to show us the two approaches so that we'll see maybe tomorrow you're working in an on-prem environment, then you understand what they use. Even if they are using traffic, F5 is almost the same configuration. So this EC2 instance here is going to run our HA proxy. All right, so this is going to be 2 servers in a private subnet. So when a user is here, so when a user is trying to access this guy, remember that these guys are not going to have what? Public IPs. So it's only this guy that's going to have what? A public IP. So when a user is here, then a user tries to do what? Talk to this guy, then they should do what? They should see this particular. Let's just see how it is. But you know what to configure. We are not in a VPC class again, all right? You know that you are going to configure what? Route table for this guy, also configure route table for this guy. Now, there's no point bringing in NATs. Now, you only use NATs if you want these guys to talk to the outside world. I hope we understand this by now. Guys, can we make the class as interactive as possible? Do we understand that we don't need NATs here unless, let's say, you have an endpoint you want this guy to reach?
Yes.
So you don't need NATs here. Just configure the different route tables for isolation. Then bring in an internet gateway so that HA proxy will be able to access the internet, so that people will be able to access HA proxy. So let us see how that turns out. So first of all, I can explicitly create a VPC if I want. All right, but because of time, I will not create a VPC. But for yours, create a VPC and make it work. All right, so what I'm going to do, I'm going to use a default VPC. Okay, so I'm going to use the default VPC. Okay, so I'll look for EC2. Please, when you are configuring yours, use the correct approach. I'm doing this because I really want to see if we truly understand what is going on. So please always form the habit of deleting your resources whenever you are done. So I have these guys running. So this is a cluster. So it does not have any business with whatever we are doing today. So I'm going to create. So I'm going to create, because of this architecture, I'm going to create 3 EC2 instances. I'll just call them servers. Then try to rename them when I'm ready. So I'll say server. Okay. So in place of, now you are not going to use this approach because you're going to do what? Create these servers in different subnets. All right. So this approach will not fly. So I'll create Ubuntu. You can use Amazon Linux. You can just try things out. So the instance type, I can leave it at T3 micro. It's a very small application. Then I already have a keeper. So this should not be our problem. Okay. All right. So I'll launch this instance. Okay. I think my capacity is up. So give me a second, please. So why I have this error message is that now our if you are running free tier, all right, so AWS is going to cap your VPC. Sorry, not VPC, it's going to cap your CPU at 16. So that means you can only create 16 CPUs in your account. So this is what it means. 16 vCPU. That's virtual CPU. So if you create a typical one instance, or a typical instance is always two, has two CPU. All right. So if you create up to 8 instances, that is 2 times 8. Okay. So that's going to give you a total of 16. I already have 6 instances running, okay, which was 12 vCPU. Now I wanted to create another 3. So I have used up my quota that AWS gave to me. So I'll need to destroy some EC2 instances. But there's a workaround. You can apply to AWS that they should increase your quota from 16 to anyone. But since this is a free account, that is really not applicable. So I had a cluster running, so I'm trying to destroy that cluster. Then we'll wait again and see what is going on. So give me a second. So I'll just wait till this guy is terminated, all right, so that I can move on. So that should take like roughly 4 or 5. So while we are waiting for what I had in my account to terminate, if you have any question pertaining to what we've done so far, please let us finalize so that we move forward.
Yeah, I have a question. Based on the reverse policy you made mention of, someone actually said engineers can also act as a reverse policy. And please, can you just explain on that? Because I was thinking in that case, maybe it was like the network gateway, but I don't know. When you said Nginx, I was kind of like, okay, I would love to understand more about it.
Okay, you know Nginx as a tool, right? As a web server.
Yeah.
Okay, now we use Nginx as a web server. So you can also configure it. If you don't want to use it as a web server, you can also use it as a reverse proxy. So that's what he was trying to say. So Nginx serves like I think 3 purposes or 2. You can use it as the reverse proxy, you can use it as a web server. So that's what he was trying to say. I don't know if that made sense.
Okay, that makes sense because I was seeing it from the web server point of view. And
Okay.
for the NAT gateway, since you said a reverse was actually relays resources before it being sent to the particular server, does the NAT gateway also provide such kind of characteristics just as a reverse
No,
POSIX?
no, NAT does not have anything to do with to do with your traffic and the rest of those stuff. What NAT is only going to help you do is you have a resource in the private subnet. Then by default, that resource cannot do what? Cannot access the internet. Now, if you want that resource to also access the internet, now it does not accept an inbound traffic. It only accepts an outbound traffic. So that's where you configure NAT. So NAT does not have anything to do with whatever we are doing. Okay.
Okay, thank you for the clarification.
All right. Is there any other question? All right. So, if I come to instances, okay. So this should be the instances we just created. Server. Okay, this guy. So let me just rename this. So I can say this is for HA proxy. Okay, so that is where I'm going to. Now, we've worked with Nginx. So I want us to see how another tool is used, all right? So, but you can, if you want, you can also read on how Nginx is used for, or as a reverse proxy. So I can call this server 1, okay? So I can also call this server 2. All right. So let's configure each of these servers one after the other. So first, let's start with server 1. So the IP address of server 1 is this. So SSH-I, then Ubuntu, the IP address of server 1. All right. So I can rename this guy if you want. All right. So I'll simply do sudo host name. Remember host name, but host name has a command called hostnamectl. So set host name. Then I can just say server 1. Set host name. Call it server 1. All right. So you can relog in. So we have server 1 here. So I'll clear this out. So the first thing is what? Sudo apt updates. Right. So the next thing is what? To install Nginx. Now, Nginx is our web server. Now, I want to use Nginx to host our web application. So that means I'm going to install Nginx on server 1 and server 2. then install HAProxy on the other guy. All right. So sudo apt install nginx-y. So it's going to install our nginx for us. So now if I go to this address, okay, I should see that our nginx is configured. So now, you know, we want to use now for observation purpose. I will just change this guy to welcome to server 1 so that when we visit HAProxy, we are going to see how HAProxy is balancing these loads. All right. So I'll just change this to welcome to server 1. So what I'm going to do is we already know where the web root is, which is /var/ www/html. So I'm just going to modify this guy. Okay. So if I do, I'll use nano, but I'll use sudo because it is in where? The root directory. Sudo nano index.html. So what I'll simply do is I'll come to welcome to nginx, where we have welcome to nginx, this place here, and I can just change it to welcome to server 1. Okay, so I'll save and exit. So I'll do sudo systemctl restart nginx. Okay, so if I refresh, I should see welcome to server 1. Are we following?
Yes.
So I'll do the same. So we are done with server 1 configuration. So I'll do the same thing with server 2. Okay, so I'm going to open another terminal for server 2. Okay, so for server 2, cd downloads. Okay, so SSH-i, then Ubuntu. By now, we should be familiar with all these concepts. This is what I am not explaining here. Okay, so again, if you want sudo host name ctl set host name
Can I ask the
to the host
question?
name. Yeah.
Okay. You know, when you're connected to server 1 or server 2, picking the SSH, then pick the the public IP and all of that. Like sometimes, like, I just connect direct? Like just going to the SSH, they just pick up every address, they just copy and paste. I can still do the same thing, right?
Yeah, sure.
Okay.
But then it's not really advisable because
Okay.
unless it's that's very possible because you're using your AWS account.
Yes. Yeah.
Yeah. Okay. So sometimes the server will be created for you and ask you to log into that server.
Oh, okay.
Yeah.
All right. I feel this pattern is more better because with this we'll be able to like type and recall everything and just copy and paste. Yeah. Thanks.
Okay. Okay, this should be server 2. All right. So I think there's a way I can log in here again. Nope. All right. So server 2. So instead of me to log out. All right. So sudo apt update and sudo apt install nginx-y. Do we know about that command? The double
Yes.
ampersand command. All right.
Yeah. So for you not to, for them not to keep asking you, yes, right? So you're just going straight.
The iPhone
So
Y for yes,
you're
but
right.
I have two different commands here. So I'm updating the server. After
Oh
updating the
yeah,
server,
yeah. You're doing
yeah,
two things at once. Yeah.
yes. All right. So if we go to the internet, all right. So let me duplicate this guy. All right. So let us reconfigure. Sorry. Let us reconfigure our sudo nano. So I'm going to give you the absolute path. Okay. /var /ww/html. All right. Then what's the name of the file? Index.html. So I can come here. Welcome to server 2. All right. All right. So sudo systemctl restart nginx.
Mr. Sammy, another question. Sorry.
Okay.
Yeah. The only way for us to like configure the server by changing any or like just change the server to from Ignis, so we can only carry that through Nano, right?
No, not really. Not
Because I
really.
noticed like you use more of Nano than Vim.
Yeah, because I prefer Nano because
Okay.
Nano is straightforward, unlike Vim. I still love Vim. I still use Vim. All right, but Nano is just straight to the point.
Okay.
All right.
Thank you.
So what you'll be doing with just one command in Nano, you can, for instance, if I want to edit in Nano, I need to press escape for insert.
Yeah.
Then all those stuffs. All right.
All right. Thanks.
So now we have server 1 and server 2. So this is our server 1. This is our server 2 configured. So now in your system or your production system, server 1 is going to have what? Your application. Server 2 is also going to have your application. But I just made these changes so that we'll see how requests, all right, comes to each of these servers. So now we are done configuring server 1 and server 2. Let us do what? Let us configure our HA proxy server. Okay. So okay. Sorry about that. SSH -i server dot ubuntu at all right. So now we are going to do what? Install HA proxy. So we update. Then to install HA proxy, we do sudo apt install, just like we install Nginx, HA proxy, all right, -y. Just give me a second. All right, thank you. So to check if HA proxy is running, we know the command already. All right, so sudo systemctl, because HA proxy is running as a service. Status HA proxy. Now HA proxy is what is active and it is running. So who remembers where your system configuration file is? Can we recall? Which folder can we have our system configuration file? Which folder in a Linux system?
Is it a root?
etc.
etc. etc. All right. So now we need to configure our HA proxy. And to do that, we will need the HA proxy's configuration file. So that means we need to go to what? etc. So if we go to etc and we do ls, we are going to see all these guys here. All right. So now we installed HA proxy. So this is what? HA proxy. And now we are seeing this in blue. That means here is what is a folder. All right. So we go into that folder, HA proxy, and if we do ls, then we can see this is HA proxy's configuration file. All the errors in HA proxy can be seen here. So this is, we are going to change this configuration file. So now HA proxy is where? Is in the root directory. So that means we do what? We use sudo. So we can use nano, then the HA proxy configuration file. Now this is what you are going to see. All right. So the first guy is the HA proxy's global configuration. So you don't make any changes here. All right. So the global is going to tell you where the HA proxy lock is stored, which is /dev/lock. All right. Then it's also going to show you the HA proxy user and the HA proxy group. Now it is running as what? A daemon. A daemon is a process that runs in the background. So whenever you start your server, HA proxy is also going to start with it. Now these are the default certificates that comes with HA proxy. So we are going to look at certifications. Now these are your default configuration And so we don't really make changes here. All right, so this, our error file, if the error is what, 400, then you visit this directory. If the error is 403, the error is 502, the error is 504. Now, our timeout server is for, I think, 5,000 seconds. Timeout connect, 5,000 seconds. And the default mode is what? HTTP. That means your HA proxy is going to do what? Is going to use HTTP as default unless you configure it. Now, we are going to add our own configuration. Now, to add our own configuration, all right, what we are going to define, we are first of all going to define the entry point. Now, we are going to define the entry point, then we are going to define what? The back-end servers. Now, what is entry point? If this is our server, we have two servers. This is our server. All right, this is server 1, and this is what? Server 2. And we have what? Our HA proxy server. So if our user is here, which is our user entry point? Please, can someone just help us? What is our entry point here?
Can you repeat? I didn't understand what you said.
Whenever you are configuring HA proxy, you need to configure two things. You configure your entry points and you also configure your back-end servers. All right. So now, this is what we are working with. This is our HA proxy server, and we have two servers running our application, which is server 1 and server 2. So this is our server 1. Sorry, this is our server 1, and this is our server 2, and this is our HA proxy server. So now our configuration says that we need to do what? Configure our entry point and our backend server. Now, looking at this picture, which server is our entry point?
It's the HA proxy.
So that means users are going to the HA proxy because
Right.
the HA proxy serves as our entry point, and this is what? Our backend servers.
Right.
Now, I am not referring to backend as application. I'm referring to backend as architecture. All right. So big because the users are not seeing these servers. This is what the user is seeing. Are we communicating?
Yes.
All right. So the users is going to see the HA proxy server. Then based on the request, the user, then HA proxy is going to forward the traffic to either server 1 or server 2. So we'll need our backend server. Now, what we are going to configure is which mode, which traffic mode, or which protocol is our backend server listening on? Is it listening on HTTP? Is it listening on HTTPS? But since we are working with demo here, our entry point, the key thing to notice that our entry point is what? HTTP. Next week, we are going to look at certificates. And that's going to be one of, I think, our last topic on networking. But for now, HTTP is what? The insecure mode of HTTPS, all right? So HTTP is working on port 80. So that means our entry point is what? Port 80. So let us see how that is done. Now, we are going to do what? HA proxy has, there's what we call a keyword. Now, for most of us that are into programming here, there's what we know as variable name. Now we have the default variable name, all right, that comes with the language itself, and we also have the ones you can define and work with whatever you're doing. Now, HA proxy has a default.
Sorry, Sammy.
Yeah.
I have a question.
Okay.
Can I go ahead?
Yes.
Please, sorry for interrupting. What I want to know the difference between reverse proxy and this HS proxy.
HA proxy is a reverse proxy too.
Oh, okay, they're the same. Okay, just the wordings. Okay.
Yeah.
Okay. But can it still act like a load balancer?
Yes, I explained that already. So
Oh,
HA
sorry.
proxy can act as a reverse proxy, can also act as a load balancer.
Okay. Okay.
Yeah. So HA proxy has kind of a variable name. All right. So if you want to configure the front end, you simply say front end. So this is where we start typing. Now for the front end, then you can call the front end anything you so wish. Anything you so wish. All right. So you can call it maybe front. Maybe you can say HTTP front. So this is just a naming convention I want to give. You can give it anything you want. All right. So this can change, but this does not change. Now the next thing we'll do is you can use your tab key because indentation is very important here. So now the next thing is what? Where is this traffic coming to? The traffic is coming to what? Port 80 because it is not secured. All right. So we can say bind. So what we are trying to say is we are binding all the traffic coming in to port 80 from all IP addresses coming to port 80. So HA proxy is going to listen for traffic on port 80. Now, it should forward that traffic. So what happens here is that HA proxy is listening on 80 here. If the traffic coming is 80, HA proxy should forward that traffic to where the backend servers. So that's what we are trying to do. Now, it should forward it to the default backends. All right. So the default backends. So you can call it anything. Backend servers. So we are almost done. So what happens is that we call the front end. All right, this is a default HA proxy keyword for defining front end. So we give that front end a name. Okay. Now we bind all the incoming traffic coming in on port 80. Now, if our traffic was coming in from where? 443, then this 80 is going to change to 443. Are we following? Okay.
Yeah. Yes.
So we can now declare our backend. So now we have asked HA proxy to forward our traffic to the backend servers, but we don't have any backend servers. So we can now do what? Configure our backend servers. So just like front end, we have what? Back end. All right. Now we can give that back end any name. Now I hope you see that we asked HA proxy to forward the traffic coming into port 80 to the default back end, and we gave it this name. All right. So that means this name must rhyme whatever we are giving here. So it's more like we are referring to this. All right. So back end servers. So the first thing we do in the back end is the algorithm type. So the type of algorithm we are going to use is round robin. So we can give it round robin. So that means HA proxy is going to use the round robin type of algorithm, all right, to balance our load. All right. Now the next thing we are going to do is what? We are now going to declare our servers. We can call this server, all right? Server 1. Now this server 1 can change to anything, all right? Server 1 can change to anything. Now we are going to add the IP addresses of these servers. But now we are not adding the public IP. Instead, we are going to do what? Add the private IP of each of these servers. Remember that your servers are going to be what in the public subnet when you are designing yours, and HAProxy is going to be what in the public subnet. All right. And when your servers are in the private subnet, your servers does not have what a public IP. They only have what a private IP. So that's the scenario I'm trying to paint. So I'll come here, paste this guy. Now our server is listening on what? 80. Now I'm going to add check. What does check means? HAProxy is going to continuously check if this server is still healthy. If this server is not healthy, then it's going to do what? Continue with the next server. We do the same thing. Server 2. The IP address of server 2. AT check. So even if you have 10 servers, you can include them here. All right. So the next thing we are going to do is
Sorry to cut short. So based on the way I see you write the variable names and the values, does that mean spaces are used to differentiate the values from the variable names, right?
You mean this space here?
Yeah, the spaces.
Yeah,
And
there are
also
spaces here.
when differentiating, like where you have the balance, the algorithm type, the servers type, server 1, server 2, I see you use spaces. So they are used to differentiate the variable name and the values.
There are spaces here. So when we start configuration files proper, you are going to see how to write configuration files. So indentation is very proper here. So if you take a look at this, all right, there are spaces here. So there are spaces here. So we save this, all right, and exit. Now there is a way to check if your configuration file is correct or not. Okay, we can check if our configuration file is correct or not. So we can use the command. So we can use the command HAProxy -c. All right. So we're trying to validate the syntax -f. -f means the file. Okay. Like -f is used to specify the file you want to check, and the name of the file is what? HAProxy. So if you check, so if you have any issue with your configuration file, HAProxy is going to return that you do what? You have an issue in so line. It's going to tell you where that issue is, then you confirm. So if your configuration is correct, you are going to see that your configuration is what? Valid. So what do? We can now restart HAProxy. So sudo system ctl restart HAProxy. So HAProxy has been restarted. But before then, what I'm going to do is, so that we really see how this guy add up, I'm going to turn off the public IP of this. All right. I'm going to turn off the, so that we will not be, so that users will not be able to access this stuff, the server 1 and server 2, from here again. So I'll come to network in server 2, then network, then there's what we call a network interface. So I'll click on the interface. All right, so it's going to output this guy for me. That is the network interface summary. So I'll click on actions, manage IP addresses. So I'll turn this off. Confirm. All right. So if we go back to our instance and look at server 2, server 2 should not have a public IP again. Server 2 should only have a private. Server 2 should only have a private IP address. Let me reload this.
Oh, sorry, Sammy.
Yeah.
In a situation where you don't have this GUI, how do you turn off the public IP from a?
Now, even when you are creating, you're not even supposed to. I just did this so that we'll see what's up. But when
Okay.
you are creating yours, you don't even have to. I hope you
Okay.
know that even if they are on the same network, you can access your server 1. Let's say you have your HA proxy instance in public subnet. Now, if you have your server 2, let's say server 1 and server 2 in your private subnet, you are not going to attach a gateway, internet gateway to server 2. So
Yes.
what this means is that you cannot use SSH. SSH happens over the internet. I hope you know.
Yes.
So what happens is that you can now use your HA proxy service. There's what we call a bastion host or a jump host. All right.
Okay.
So you can access your server 1 and server 2 from your HA proxy instance. I don't know if that made sense.
Right.
Okay.
Oh.
So let's try to change. So if you notice, there is no IP address there's no public IP for server 2 again. All right. Server 2 only has the private IP. So even if I come back here, if I come back here and try to refresh, we will have nothing. Okay. So we should have a 404 not found error. Okay, so this is, it has cached already, so it's going to take a little while. Okay, so that's literally what happens. So don't know why this is taking too much time to load up. Okay. So I think I'm running out of some. Sorry, my PC is a bit slow. I have a lot of processes running. So, okay, I think I'll need to stop some process. All right, but then This should be our HA proxy. All right. So let me try to get the public IP of HA proxy so that we'll see what happens. I think this is the public IP of HA proxy. So someone should try to access 100.54.22.246. Then you can see for yourself what is happening behind the scene.
Can you post it in the chat, please?
Yeah, I'm trying to do that. So I've done that. So someone should try to visit that. So while we are waiting, so this is what is going on. So the first request comes to server 1. Let's assume the second request is coming. So I can reload this. All right. So the second request comes to what? Server 2. So the third request comes to what? It's in a cyclic mode. So the next request goes to server 1 again. And the next request goes to server 2. The next one goes to server 1. Let's assume that server 2 is not healthy. So users are going to requests will be going to server 1, server 1, server 1 until server 2 gets healthy again. So that's literally what happens. Is there any question?
No.
Okay. So I think this is it with load balancing. All right. So AWS has a most straightforward solution. Okay. So with that, what you do is you come to your EC2 tab. Okay. Then you can see load balancers. Now click on load balancers. All right. Now if you click on load balancer, we don't have a load balancer. Okay, I have 0 load balancers, so I can create a load balancer. Now you can now choose the type of load balancer you want. Is it an application load balancer? Is it a network load balancer? Or is it a gateway load balancer? Now, if your AWS account is very new, you may not be able to create a network load balancer. You may not even be able to create an ALB, but you can try it out. So what you'll be able to create is what? The classic load balancer. All right. So the classic load balancer is more like a deprecated version of the network load balancer, but still works very well. Okay. So if your account is very new, this is what you'll be able to create. So we click on create. All right. Then you can give it a name. You can say maybe from application, web app. All right. So now there are two types of load balancers or the scheme. Is it internet facing or is it internal? Now we are creating what? An internet facing load balancer because this is what users is going to use. All right. So if it is an internal, is like, let's say maybe, most organization has internal application, all right, that they use to maybe things like resolve issues for users. So you can use internal, but since you are working with internet facing. So we go with internet facing. Now, what do we do? If you are creating the AWS load balancers, AWS is going to ask you which VPC are you creating the load balancer is, or which VPC do you want the load balancer to work on. So we can choose what? I only have this guy, so I'll choose default VPC. Now in the availability zone, okay, I can choose any of these guys from availability zone. All right. Or even if I don't choose, okay. So you can choose any of these availability zones. All right. So then you can come here and do what? Create a security group. So you can use the default security group, but if you have yours, then attach yours. Now there's what we call listeners. Do you remember when we were configuring our HA proxy? Where we configured where HA proxy should listen on, which was the port 80. So this is where you configure listeners. So the listening protocol and the instance protocol, all right? So 8080. Now you can add different listeners here. The application is listening on port 443. You can change this to 443. So you can add up to 99 more listeners. Then you can configure health checks. All right? So load balancer is going to automatically configure the health check for you. Now, the next thing you're going to do is to add instances. That is what we did. All right. So we can add these three instances. 1, 2. Confirm. All right. So our HA proxy is in US East 1A. So we can put that in US East 1A. Okay. So what again? What listeners is active. What again? Then connection draining, cross-zone load balancing. All right, so I think this is all. So we can now create a load balancer. So if we create a load balancer, what do? We come back to load balancers and do what? And okay. So we'll give it some time for AWS to provision a load balancer address for us. So the address should pop up here. Okay. The address should, okay, this is our DNS name. All right. These are DNS, so we can copy this DNS name. And I don't know if I use the correct security group. So I can come here. Okay. So I think I used the wrong security group. So, but this is how AWS provision load balancer. So
Yeah,
why it's not coming up is, yeah.
Yeah, and where can we configure the type of algorithm for this?
So by default, this guy use round robin.
Is it the weighted or just the normal round robin?
For the AWS native load balancer, let me try to confirm. So now for AWS use the round robin. All right. So it used the round robin plus the list request. So it does not use the weighted. It used the main round robin plus the list request because sometimes you get to create almost all the instances the same. Now, if you're using application load balancer, AWS use the round robin, but if you're using network load balancer, we remember the IP hash algorithm, right? So network load balancer use the IP hash. Now, the classic load balancer, before now, we only had classic load balancer, but the classic load balancer is what is now divided into application load balancer and application and network load balancer. So all right. So this is it. So you can play around with this guy. Then next week we'll look at TLS.
Thank
Then
you.
any question? Is there any question?
No.
All right. So since there are no questions, then we are going to stop here for today. We are going to stop here for today. Then tomorrow, sorry, I'm going to drop the tasks we have to do on the group. All right. Then on Saturday, we look at the very different concepts. I think that will be our last in networking. All right.
Okay.
So I'll stop the recording now. And the recording will be ready, or I will send the recording to the group when it's ready. Thank you.